So we're going to go kind of just quickly through this a little bit, to kind of just as a quick reminder about modes of action. And so this has been adapted from some things that Dr. Shetler did and some other things that Beth Sheckelhoff did. So I want to thank them for that. So now is a great time to go back through your scouting notes. When did I see what pest on what crop? Begin to kind of take a thorough look at all of that, because I know that all of you are busy buying chemistries right now. And it'll kind of give you an indication, especially if you've got records back 2 or 3 years, kind of to take a wider look, because 1 year is just a simple snapshot. We look at a couple 3 years back, we're going to get kind of a better picture. And when we think about all the strategies that we have, and so we've got the cultural, we've got the physical, thanks to Valerie and folks like her, we have the biologicals now for some of the things. But truthfully, I mean, when we look at what's available to us, tolerance is not something, tolerance and masking only go so far in what we're doing. We really need to be out there putting the biologicals down as a preventative. But when we actually get to the point where we have real populations and we have to think about curative and rescue, and that really is going to take us to our chemical tools. And our chemical tools are among the most expensive things that we have, both in personnel. And from what you all have shared with me, I went into cost shock when you guys were sharing with me what some of those individual drums of chemistries actually cost. So we're going to talk briefly just about modes of action, a little bit about reasons for failure, and I'm going to give you a couple of links at the end that you can use at any time. You can also reach out to me, of course. So when we think about the synthetic organics, those are the most common of our pesticides. We've got some inorganics. So we're talking a little bit earlier about using some copper. Relatively few botanicals. So these would be things that are made from plants, and fairly few microbials, although there are some of those are actually are in development now. So when we think about the synthetic organics, I just pulled this from a list of modes of action for insecticides. And you can see some of the most common ones, and those are the numbers that are at the tops of the bottles. But I thought this was really important when you're thinking about what chemistries to buy. It's how many of those individual active ingredients are actually classified together. So when we talk about rotation, we're not necessarily talking about rotating an individual AI, we're talking about rotating within groups. And if you look at those organophosphates, there are probably about 40 different active ingredients there. And even among the neonics, there we've got diatefuran, we've got imidacloprid, we've got a few others that I know we use kind of on a regular basis. And you go, well, I used diatefuran, I used imidacloprid. Well, both of those were within the 409 neonicotinoids. And why this is important is when we think of a mode of action. So, and I spared you guys all the biochemistry. I was going to put in a pathway and figured I'd lose you all immediately. A pathway is just a series of steps. And so when we're thinking about a mode of action, it's going to affect an individual pathway. And so we've got neurological pathways, we've got metabolic pathways, we've got cell membranes, which are the things that hold all of the stuff within cells. With insects, we've got things that can damage their cuticles. And then, of course, we have growth regulators as well. And so within any one of those systems, then we're going to have specific chemicals that are going to target within that process. And then a site or target is going to be one of those individual steps within that pathway. So you've got that single step, and these are just a few individual enzymes within that step that we're talking about. And so if we look at this, and so this is courtesy of Dr. Shetler, we've got the pyrethroids. So those are going to be the channel blockers. We've got acetylcholines, the carbamates, Those are the acetylcholine esterases. And we have similar things in us, which is why some of these things can actually be very toxic to us. And then we've got the acetylcholine receptors. And so we can see each of these different groups is going to target a different place, right? And so let's take a quick look at this. So I was called out to look at aphids earlier this week. So I picked aphids as my target. So let's say we were spraying merit, for example. So that's a neonic. Here we have this population of, this is about 100 aphids here. And so if I spray merit once, I might find one individual that survives. And so that one survival, because aphids reproduce parthenogenically, all of its daughters have the likelihood of carrying that same resistance. So if I spray, but we've got right now, we have a huge population of aphids out there. So at least the place I was at this week. And all of a sudden, so all of her daughters have the dark blue circles. So we're still okay. We're still at only about 10% of them having resistance. But if we do this a third time, now look at how many of them are resistant.
Oh, kind of blurry.
Oh, I didn't mean to shake the table. And so at this point, the decision really becomes critical, because if we apply merit again, we're basically selecting only for those that are going to have resistance. And because that's a neonic, and because there's what we call cross resistance, which means a chemical within a given group, other chemicals within that group are not going to be either effective at all or as effective as we would expect. So if we try TriStar, now we have maybe found one other one. So this individual, see if I can point to it. So this individual in orange, it does not have the neonic resistance. It has a different resistance. And that's one way that we can slow down development of resistance, keeps our chemistries around longer. It also is going to help us to support what's the word I'm looking for? Basically, a population dynamic. So how do these things actually reach insects? So typically when we're thinking about this, we're going to think about contact. Some of them they're going to eat. Inhalation is not as much of an issue sometimes. For some of the neonics especially, we can get some systemic, so they'll be taken up. And then as the insects feed, so it's still going to sort of be a stomach contact. But truthfully, contact, inhalation, those are the ways that we come in contact with these as well. And that's kind of the take-home reminder for some of this. Remember that LD50 is the lethal dose 50, and these can be for oral, which is swallowing it, dermal, which is getting it on your skin. Inhalation is probably the most deadly of these. And I put this up here just to kind of give you an idea of what this actually looks like. I'm going to see if I can just move this over. So you can see how variable and among these neonics. So everything from as low as 217 up to over 5,000. And you might think, oh, that's just neonics. But if you look at pyrethroids, which disrupt nerve sodium pumps, and we have these too, amazingly enough, you can see how low down to 75, once again, up to about 826. So you're going to be looking at those labels, and we tend to think of and put more emphasis on the importance of looking at labels for insects and how those chemistries might impact us. Please remember, fungicides come with their own set of warnings. So this is Concert 2. Notice that this one is danger. Chlorothalonil comes with warning, and trimethyl comes with caution. So all three of them, and these are all three that we use on a regular basis.
Never seen Banner or that one.
And if we look at it here too, especially because when we're treating for powdery mildew, when we're treating for some of these other issues, we know that we're applying these on a regular basis. And we have the added disadvantage with fungicides, with fungus in general. When we have insects, we can treat when we see them. With fungi, we need to actually do it preventatively. Because remember, when we're talking about how fungicides work, that coating needs to be there so that when the spore lands, we actually kill the spore. Because for the most part, our fungicides are not curative, they're only preventative. And so through FRAC, which is basically, it's very similar to IRAC, we've got the codes. I looked at most of the chemistries we look at. We use 3s, 7 and 11. That's right. 7 come 11.
Yep.
And so we need to, where possible, begin to look at, can we use T-methyl? Can we use something in group 1? Can we use something in group 3? Herbicides, couple of words just to make sure that you remember what these mean. Translaminar means it's going to go into the leaf tissue, but not move through that leaf tissue. Translocate means it's going to actually either, if it's going to be basipital, if it's something that's going to go down into the root system. If it's a cropital, this is going to be something that's going to be taken up from the root system. Longevity of herbicides, there are a number of factors that come into this. The contact, the organic matter can be really crucial. As we've experienced a little bit this year, some of the chemistries are actually very mobile in water. And so even though we've done the application right, it can actually move through water and actually be taken up through that root system and actually show up later. So we've got to pay attention to that because the systemic, so we've got after it's initially applied, after it's initially translocated, and as it continues to be translocated.
That's why I don't spray where there's plants in
So-
containers. Just because of that. They keep wanting me to spray, but I keep telling them I can't.
You should
It's gonna
work with
go-
us in the field.
I know how it is. But I mean, in the
And that's all
container,
we gotta do, spray around the plants.
no, but that's in the field, they're in the ground. In
Yeah.
a container is a
But-
different animal.
But even so, the concern is that as these chemistries have changed and what we have available to us has changed, it really is going to impact. I'm trying to remember the one that we talked about in Beagle this morning. It's one that basically will move not only, I mean, it will move with water. And so we got, an 1.5 inch rain. It's going to wash off the plant. It's going to wash into that water and it's going to get translocated. In terms of greenhouse weed control,
That's the reason why I refused to do a herbicide tonight, that was asked to.
absolutely.
Well, that plateau, which is what caused all the damage in the junipers, you could see in the one field that the way the water went, that's the way the death and destruction.
Yeah, they could follow the water.
It took, so we had fields of taxes and they had bindweed seriously bad. So I put plateau, I went right over top of them and it knocked the shit out of them. And so we used it obviously less and less because it was pretty much eradicated. Well, then they put junipers and
Chemiciferous.
Chemiciferous in there, and they did not like that. So every time you could see where it was sprayed and not sprayed, it looked like either aerified mites or let's see, other one that used to get titmidge. And there was one I can show you a picture that looked like somebody trimmed this to look like a topiary thing, and it was actually one that's supposed to be weepy. And it still moved bad.
Yeah.
And it took 2 years to get that out of the.
And that's the other thing, and that's the residuals for some of these things are incredibly long.
And I only knew that because we sent stuff to Purdue. They asked me, of everything I could have possibly sprayed, whether it was, fungicide, fertilizer, whatever, and I listed everything.
Just like
Oh, you
they,
said it was herbicide?
Yep, and
I thought it was herbicide myself,
They concur.
but I couldn't, we couldn't pinpoint which one, and that's one we didn't think of.
Yeah.
yeah, it's just like when we do our cover crop in the field, I told them, what are the plans for? Some of the fields I just let go because I know that the crop that's there, it's gonna be gone by the end of the year or sometime the following year. And depending on what chemical I use, is gonna be the residuals. Sometimes they say, no, we're not taking it out, and all of a sudden they go in, wipe out the field, and they wanna put cover crop right away. Then they see nothing coming up, or they see some of it coming up, but not the other stuff.
Yeah, and then
It's
they
like-
send me to sample the soil.
And then they're sending soil samples to Hector to find out what's wrong.
Going
It's
through
like
all the
that field
fields.
next to Mr.
sample the
Lee's,
soil.
I put, Marengo
Yeah.
over that, and then they came in, messed it up, put cover crop, and the cover crop didn't.
Yeah, so the cover crop don't come out. Why? Because
They've got herbicide.
they said
Well,
they're
they-
not harvesting anything, and all of a sudden they.
Exactly. And so, in fact, you see Marengo's right up there at the top of the list because I know that that's one that we've used quite a bit. So if you're going to be using this in any kind of a covered situation, read those labels very carefully. Pay close attention if you've got any plants in there whatsoever. Things are going to influence the longevity. Phytodegradation is going to be significant. Microbial interaction for some of our compounds is significant. The formulation. So when you're going to purchase, you can purchase emulsified concentrates. You can purchase something that's encapsulated. Generally, the encapsulateds are going to be more resistant. The wettable powders are going to be some of the most easily degraded. And remember that a bunch of these things will bind to organic matter as well. Why do products fail? Timing, mixing compatibility. So you're trying to put 2 or 3 things together. Always do a jar test for that. Things break down over time. And then if something has worked and all of a sudden you begin to see where it's not working, whether that's on a weed or whether that's on an insect or whether that's on a disease, that's a time to have me come out or have someone come out and actually take a look, because if something's been used over and over, do we have the possibility of actually having resistance there? Couple of label changes that are coming through from ODA, just to make sure you're aware. A bunch of the nursery chemistries are going to be reviewed. We're up for that 15-year review. We started the year talking about the Endangered Species Act. They're continuing to put that onto labels, so look for some label changes there. On herbicides, check the active ingredient and the concentration, because they have reduced the concentrations in some instances. And then there are some things that are actually moving from general use now to restricted use. Nothing that I've seen that I hear that we all use, but some of those things are coming down the line. And these are the 3 websites. So the one for insects, the one for fungus, and the one for herbicides. If you don't have the herbicide take action poster, I can get that for you. It's mostly meant for agronomic use, but you can look at the active ingredients and see what groups they're in. So